Welcome to this presentation. The title is Analysis of Industry 4.0 Products in Small and Medium Enterprises. Although I am going to be the speaker, I made this presentation and all the background work with Alicia Mon, and in fact we are part of an interdisciplinary research group at the National University of La Matanza in Buenos Aires, Argentina. The technological transformation generates an increase in the heterogeneity of the industries, deepening the structural gap previously existing to the fourth industrial revolution. The gap in the digitalization of companies in Latin America countries is widely significant, and it's a risk of increasing in the coming years with the accelerated evolution of Industry 4.0. The Inter-American Development Bank created a Conditional Digitalization Index based on the digital tools currently adopted by companies, the digital scenario in which each company hopes to be in the future, and the level of preparation to achieve these objectives. However, it does not detail which technologies are available or which are adopted by the companies. It doesn't focus to the products that make up Industry 4.0. With these instruments, the Inter-American Development Bank carried out a comparative study between Argentina and Brazil, and the results expose a worrying panorama about the perception of the companies themselves towards digital transformation. From this perspective, given the speed of the transformation processes and the company's lack of knowledge about the decisions to be made, we saw that it became necessary to have some instrument to know where we are. And this is the problem that we try to solve by constructing an index that measures the adoption level of ICTs in the industry. For this purpose, we created the Intix Index in our research group, which is called HIS, Grupo de Ingeniería de Software. This index evaluates the level of technological development of each industry according to the software, hardware, and infrastructure products that has been implemented, currently fulfilling specific tasks in the different functional areas. Now, I shall give some background regarding the way we created the index. Regarding ICTs, software, hardware, and infrastructure are three elements that exist and need each other. They need to work in an associated way because hardware requires a software to work and also a communications platform, infrastructure, to be interconnected with the rest. We have made an adaptation of the Michael Porter value chain matrix linked more to the processes of our local reality, and finally, the following industrial processes were defined. These are the industrial processes that we define according to our local reality: management, finance and accounting, engineering, purchases, logistics, production, and sales. In this double entry table, we crossed the intersections in which some type of possible relationship is presumed. The other intersections were grayed out. Once the intersections have been identified, the idea is to assign a weight or value, 1, 5, or 10, to each possible intersection, according to the development level of each ICT in each industrial process. In fact, this is the same table as before, in which we have changed the crosses with evaluations, which could be, as we already said, 1, 5, or 10. Then we have the survey form. This is the form that has to be filled out in each surveyed industry. In fact, this is the same table as the previous ones, but the space that previously had the crosses or the evaluations is now blank. Here is an example of a survey in a particular industry. Next, the crosses are changed by the values of the matrix table, then all these values are added, and finally the ICT adoption level of that industry is finally reached. Then, look in the slide, and depending on the range of values, that surveyed industry will have a basic adoption level, medium or intermediate adoption level, or advanced adoption level. It's very important to mention that our index only considers the degree of insertions of ICTs. We do not get into the detail of the industrial processes. We only consider them to make a cross between the ICTs and these processes. The ICT products identified by the index are 74 in the different functional areas, within which those corresponding to the basic level are 20, those of the medium level are 30, and those of the advanced level are 24. Not all the products included in this last advanced level are of the latest generation, but they are essential for the integration and operation of the others. Therefore, from this set, it is possible to extract a subset of specific products from Industry 4.0. This slide shows the specific products of the index that, when integrated, make up a subset of products of Industry 4.0. The study was carried out applying the Intix Index in La Matanza, the largest district of Buenos Aires, Argentina, with 2 million inhabitants and 7,000 industrial establishments from different sectors of the manufacturing industry and conformed by small and medium-sized companies. 40 industries of various branches were surveyed to determine the level of technological development and to detect the existence of Industry 4.0 products implemented in local companies. The study was carried out through a digital survey and is accessible via the URL reference that you can see in the slide. We can see that most industries have an ICT adoption level between basic and medium, and we can see the different percentages and profiles of the surveyed companies. Micro companies up to 15 employees, small companies up to 60 employees, medium category section 1 and section 2 up to 235 and 655 employees respectively, and large companies more than 655 employees. From the analysis of the results applying the index, of the 40 industries surveyed, 62.5% are in the basic level, 35% in the medium level, and only 2.5% in the advanced level, as we can see in the slide. There are 3 companies that have augmented reality software implemented, belonging to the metallurgical sector. 1 large company, 1 medium-sized, and 1 small company that apply this type of technology to product and process design systems in the functional areas of sales and/or production. Of these companies, 1 has an advanced level according to the ICT index, while 2 have a medium level, as shown in the slide. The companies that have virtual reality software are 3, 1 large, 1 medium, and 1 small company, of which 2 are from the metallurgical sector and 1 from the paper industry. Its implementation applies to product and process design systems for sales and/or production functions. Of these companies, 1 has an advanced level according to the ICT index, while 2 have a medium level, as shown in the slide. There are 6 companies that use big data software, and their implementation is applied for management systems that combine information from different functional areas, such as management, accounting and finance, sales, purchases, logistics, and/or production. Of these 6 companies, 1 is a large company and 5 are medium-sized. 2 of them produce in the metallurgical sector, 1 is a plastic manufacturer, and 3 belong to the software and computer services company. Of these companies, 1 has an advanced level and 5 are located at the medium level, as shown in the slide. Regarding the use of robots, from all the 40 industries surveyed, 6 have automated plants with the assistance of robots for production, 3 of which are large companies, 2 belonging to the food sector and 1 to the metallurgical sector, in so much so that the other 3 are small companies in leather and metal branches. Regarding the level of development detected by the index, 1 is in the advanced level, 3 in the medium level, and 2 of them in the basic level of ICT implementation, as shown in the slide. There are 11 industries that have sensors. These devices are used by all those industries in their production line, while some complement them with devices installed for the engineering, logistics, or sales area. Regarding its level of development evaluated by the ICT index, 1 company is in the advanced level, 9 are positioned in the medium level, and only 1 in the basic level. Regarding their conformation, 2 are large companies, 3 are medium-sized, 4 are small, and 2 are micro companies. Regarding the branches, there is a variety of sectors such as metallurgical, textile, leather, food, and paper, as shown in the slide. 13 companies have networks for the Internet of Things. This technology has been implemented by 10 companies that have sensors installed, 2 that have robots in their plants, and 1 company that has reported that it has this infrastructure but does not declare any device installed. In all cases, they use this infrastructure in combination to carry out tasks in all the functional areas of the ICT index. Of these 13 industries, 1 is in the advanced level, 8 are positioned in the medium level, and 4 are in the basic level. In terms of its conformation, 2 are large companies, 5 are medium-sized, 4 are small, and 2 are micro companies. Regarding the branches, there is a variety of sectors such as plastic, metallurgical, textile, leather, food, paper, software, and computer services, as shown in the slide. Regarding 3D printers, 5 companies that have this equipment have been surveyed. 2 implemented in the management area, 2 in the sales and engineering areas, and 1 company combines the use in production, sales, and management. 4 of them integrating the metallurgical sector, and 1 to the software and computer services sector. Of these industries, 1 is located at the advanced level and is a large company, 3 at the medium level and its size is medium, while only 1 located is in the basic level and it's a micro company, as shown in the slide. Regarding the cloud computing service, of the 40 companies surveyed, 16 are those that use this infrastructure in a combined way to carry out tasks in the 7 functional areas of the ICT index. Regarding the branches, 5 belong to the software and computer services industry, 4 to the metallurgical sector, 3 to the plastic sector, 2 to the food sector, 1 to the textile sector, and 1 to the manufacture of electronic components. According to size, 2 are large companies, 7 are medium-sized, 6 are small, and 1 is micro. 1 of the large companies is at the advanced level, while 10 are at the medium level and 5 are at the basic level, as shown in the slide. There are 6 companies that use software with machine learning, of which 1 is in the advanced level and 5 in the middle level of the index. In all cases, its implementation is applied to management systems that combine information from different functional areas of the company, such as production, logistics, sales, and/or management. According to size, 1 is a large company, 3 are medium-sized, and 2 are small, while 3 belong to the metallurgical sector and 3 to the software and computer services industry, as shown in the slide. Regarding the implementation of software with cybersecurity, 16 industries use critical infrastructure security systems to perform tasks in all functional areas of the company. Regarding the branches, 5 belong to the software and computer services industry, 5 to the metallurgical sector, 3 to plastic, 2 to food sector, 1 to furniture sector. According to the size, 2 are large companies, 7 are medium-sized, 6 are small, and 1 is micro. 1 of the large companies is at the advanced level, while 10 are at the medium level and 5 are at the basic level. 10 out of 16 industries use cybersecurity as a complement to all the functional areas, as shown in the slide. Regarding the availability of energy control software, none of the 40 industries surveyed has technology aimed at energy efficiency. We have introduced the results of the application of the Intix Index, which allows evaluating the level of technological development in manufacturing industry discriminated by region, branch of activity, and company size. The analysis carried out distinguishes between existing technologies and trends in the development of specific products, which provide companies with knowledge about the implementation and integration of necessary software, hardware, or infrastructure. The knowledge of the specific products that make up Industry 4.0 would ease the definition of a technology adoption process. The results of the study allow us to state that the application of the Intix Index has made it possible to know the level of technological development in a set of companies evaluated, located in an industrial district of Argentina, analyzed by branch of activity and size. It also allows us to evaluate the proximity or distance that is found in the transformation to Industry 4.0. In this sense, as we said in the beginning, an important technological gap is observed between a large multinational company that contains advanced products and modes of small and medium enterprises which are in the same district, the last ones incorporating technology without a strategic vision about the functions they need to deploy to increase their productivity and being very far from the transformation towards Industry 4.0. Alicia and myself have written a book in which we explain all of this with much more detail. The book can be downloaded for free from the website mentioned. Unfortunately, it's only in Spanish so far, but we don't have any problem to help with the translation. In fact, it would be a pleasure. Once again, thank you very much for taking the time to listen to this conference, and here is our emails in case you want to keep in touch.